folks, welcome to the next video in my series where I attempt to create my own Mega Drive game. Now, I recently posted a video where I discussed some of the high-level design decisions, and I must admit I've been struggling with analysis paralysis. I know there are a lot of things I need to take care of, but I'm struggling to choose one to do first, which means I haven't done anything at all. Unfortunately, that can be a common problem with software development for personal projects and commercial. Experience teaches you that sometimes you've just got to rip the band-aid off and do something so that you're not sitting still. So this video is going to be me introducing a way to switch between key game states. What do I mean by that? Well, there's going to be different games within the game, so to speak, or programs within the game, each one representing a different state. To help with the explanation of game states, let's take a look at an existing Mega Drive game, and I'll discuss how what we see in the game might reflect different states in the game software itself. So we'll switch over to RetroArch, where I am running Contra Hardcore for Mega Drive, and the first thing we're going to see is a copyright license screen that comes up as soon as the console's powered on. So you could say that that would be the game boot state. Now we're showing the Sega logo, still part of our boot startup. Splash screen state. That would be a program with its own palettes and sound effects and everything. And I probably need to turn that down. Okay, so we've gone through the boot up state and there would have been some initialization for the game to get started. We've gone through the intro state. We're now in start. We go back to the intro state. So this will be a sub-game loop that's running, and we can skip that, which moves us on to the menu state, where if we select one or two players, that would take us into the actual gameplay state itself with its own sub-intro and everything. And options, we've got a different menu. Here we'd be configuring game variables. So these menu interactions and parts of the gameplay experience would be managed as states. And the benefit of states is it allows us to compartmentalize pieces of the game and make software development and management of the code and the game much easier. Now, while dealing with my analysis paralysis, I have been experimenting, making my own little demos, and just becoming familiar with some of the features, and honestly making some code examples based off watching Pigsy's excellent retro game dev tutorials. You would have seen the outcome of the code that I have in front of me here in my recent high-level design discussion video. I think it was the third video in this playlist. And that basically started out with, we've got our main loop here where the system starts up. So we're in the initialization state, I guess you could say. In our main loop, we use the C language switch statement to basically check the value of a specific variable, current game state. It keeps track of what it says on the tin. Each case is essentially a block of code that will happen if this variable current game state is equal to this, then we will run this code here. The break is necessary because if we don't have that in the C language, once it's run this block of code, it will then just keep falling through and executing all the rest of the statements until it hits the first break or it gets to the end of the switch statement itself. We've got main menu state, which will start out as the default. We initialize that up here, where we define the current game state. Then we've got credit screen, how-to screen, and what I call the playground screen, which was just the idea being I could put any old thing I want in there to show off and play around. Let's take a look quickly at our main menu state. Now, this is essentially a game loop of its own. So we've got a bunch of initialization stuff where we set up the VDP to draw some text and a menu showing us what each of the buttons will do. We install an event handler for joystick button presses. Then we essentially jump down and run the system do vblank process, which you need to run for every frame to keep SGDK ticking over with its own internal processes, making sure the system updates as need be. If you have been following Pigsy's code, a lot of the time this ends up at the end of the main game loop. But if we're switching in between states, we just need to make sure each state with its own game loop of sorts runs this as one of the last things it does for each frame. And how do we change from the menu state? Well, our event handler, which is up here, alters the setting of the current game state global variable to whatever it needs to based on the button that we press. This one here is me testing out what might happen if there was an unknown state variable. I forget what I was trying to achieve with that, but that's all that is. Okay, so if we press button A, for example, then we change current game state to the credits screen state. And you'll notice that our game loop here is not running while true, like again you may have seen in some of Pigsy's demos. It's running while our current game state matches what we expect, which in the main menu should be G state main menu. If it's changed, like in our button press handling code, then this will exit. We will leave the main menu state and go back to the code that called that, which will be here. And on our next loop through, when we discover that the current game state is set to G state credit screen, we then go off and run the code for credit screen. And the credit screen implementation essentially goes through its own initialization stuff, draws some more text. I give thanks to and a shout out to Pigsy's Retro Game Dev tutorials. Do check them out. Set some palettes, and I think there was a point where I was showing text from an actual image. I don't recall. Similar to what we saw in our main loop, we've got a handler to respond to button presses and change the game state if need be. Other than that, our main game loop for the credit screen state just keeps running while we're still in the credit screen state, calling our vBlank process for each frame until it changes. So that's a very rough idea on what I'm talking about when I say I want to introduce game states. Now, if we have a look here at the Project Explorer in my IDE, we'll notice that we've got main screen and what appears to be a credit screen, how-to screen, playground screen. We've got a C file for each of the screen states. That's going to help us break up our code. So for example, credit screen has the credit screen state that we looked at before. That's nice and succinct. It's all about the credit screen. Similar with the how-to screen, which is just another state that you could select from the main menu. And our main menu itself is implemented in main.c. That will probably change. So I think with this video, I might just get started in like a train of consciousness while I edit the code and see how it goes. So I think the first thing we want to do is strip our main function down to just the minimum that we want. And for that, we'll even remove this palette manipulation stuff for now. We'll keep the bulk of this state switching code in our main loop. We'll just comment this and say main outer loop. And let's focus on main menu. Now, main menu itself is still within our main.c. Let's shuffle that around. So we'll create a new main menu.c file. First thing we want to do is let's cut out our main menu code, the joystick handling code, and that's probably a good start. So we'll bring this across to main menu.c. You would have seen that in our header files, we need to have pre-declared or created a prototype for the functions in our actual C files. For main menu and main menu joystick handler, we would need to create separate prototypes in main menu.h. However, if we change the main menu joystick handler, adding the static keyword to the beginning of the function definition or signature, what that will mean is that to the C compiler, main menu joystick handler will not be visible outside of main menu.c. No other code really needs to know about it. If other code does need to know about it in future, we can always change that. So what main menu.h is going to need is a prototype for this. So we'll add that, and we need the extern keyword to say that, hey, the main menu symbol is external. So it's somewhere else in our program. And we're seeing here now that main menu cannot be found because we've pulled it out from here, from our main.c, but we have not included our main menu header file. So what happens if we compile that? Resources.h, no such file or directory. I think our resources are in a bit of a mess, which doesn't really surprise me. So what do we need to edit? We need to edit our... Oh, there are no resources defined at the moment at all, which I think is okay. We just need to comment that out for now. Let's just get this compiling. Oh wow, we've upset a whole bunch. What have we done here? Okay, credit screen is now referencing a bunch of stuff that doesn't exist anymore. Let's strip the credit screen all the way down. That's right. I was previously drawing an image of like a gear, a cog. Let's cut that out. We will leave that text in. I think we won't need this tiles index variable for now, seeing as we're not putting tiles into the VDP. We're just using SGDK's text. Okay, compiling. No, what now? Okay, main menu.c is missing genesis.h for SGDK, of course. And now our state definitions are not included. Where did I put those? Our states are in constant.h. We will actually go and we'll change constants.h to, we'll call this state. Game states, because we might end up with the concept of like enemy states later on, so we'll differentiate. Okay, so now to our game states we need to say extern because it lives in a separate file. What type was that? We had some stale references to the current game state symbol, so a clean of the project and a rebuild has worked. Let us see what we get now. We'll run this up in ClownMD-emu. So we have here our very simple menu. Let's see if it functions as desired. A, we've got credit screen. Nothing happens until we press start. We go back. So we change to how-to screen, and C, playground screen. Okay. So coming back to our main.c file, that means that we've got the basics of our state handling where the main menu now lives in a separate file of its own to help split things up. And we can switch between 3 other states. So what else do we have here? We might... menu palette data. I think that was a holdover from me experimenting with programmatically changing up text color. We can probably remove all of this. Let me just check. Nope, it's not used anywhere. Global text buffer, I use that if I need to print strings. We'll probably want that sooner rather than later. I think the prototypes for the menu apps that I've written in the comments, essentially our separate states, I think these prototypes are best put in our dedicated game states header file. So we will remove those from there and put them into game states. Okay, and we should add one for main menu screen as well. For those that might be curious, I've just took over half an hour of real world time on this recording. Okay, so our main loop is very, very clean and concise. Now one could argue that I could probably remove this default fallback where we check the game state. I might leave that there for now. Okay, well, what next? Let's go and make our menu screen a little bit more interactive, shall we? So we'll go over to main menu.c. Now what I'd like to do is replace this static text that tells you push this button for X, Y, and Z with a cursor that we can sort of move up and down with the D-pad on the controller to select different things. So for that, we're probably going to want a list of data structures which represent each of the possible things that can be selected. So let me sketch out what that might look like. Okay, so I've sketched out some very simple data structure which should hold details of a menu entry. So we've got a label that we will print and the new state value, which is what will what the current game state variable will get set to if a given menu item is selected. So then, of course, we're going to need a variable which keeps track of the actual current menu selection. And then we will want to split out the menu drawing code into a new function that can reflect changes in the selected item when we press up and down. Let's first of all cut our menu drawing screen, our menu drawing code. I think we can cut all of this text stuff and put that up in here. Leave the joystick handler, and we will call draw main menu to update it every frame in our game loop. Does that still work? Yep, we can still change stuff as we expect. Excellent. Now what we will do is we will iterate through our list of menu entries that we have here, going down, printing them out, and adding a little cursor arrow next to the one that is indicated as the current selection. So let me quickly sketch out some code for that, and then we'll discuss it. So I've finished some changes to the menu code. Oh, we still have this text here. Let's comment that out until we're proven that we don't need it anymore. Our draw main menu loop now has a couple of constants in it. Now, a key thing to note is these hash defines, they're actually C preprocessor macros. What that means is wherever this menu top row is encountered, this text here, whatever it is, will be substituted, and then the compiler runs over it. Now what that means is that this will allow us to save some space in some instances where, say, small integers, for example, can be encoded sometimes within the actual instruction bytes themselves rather than having to take up RAM. So that can be useful at times. There are pros and cons to using defines versus constants or actually modifiable variables, but for now we're just doing this to make our code a little more flexible. The menu top row, that's basically the Y value where we will start printing our menu lines. Cursor width, we just use that. Actually, that's not used at all here. Okay, and then menu XPad is how far across the screen we go before we actually start printing out labels for menu entries, taking into account that we'll want some space for the cursor as well. So we just have a for loop which iterates through all of our entries. Now I'm not using I here, I'm using a more descriptive variable name because that's just good practice. It wouldn't be the end of the world if I used I here, but I would rather have a more descriptive variable name, even in my loops. At compile time, size of will sort of calculate the size of the main menu entries array and divide that by the size of each of the entries to give us sort of a more dynamic calculation on how many entries are in this list here. So the way I've structured that code, I guess I'll demonstrate it shortly. We should be able to easily add a new entry here and then just have our menu handle that just fine. In the loop, not much happening except if the current menu item index in our loop matches the current menu selection, then we will draw just 2 lines and a greater than sign for our menu cursor. Then we will draw the label. We've still got our main menu joystick handling code here, and all that's doing now is when we press button A, whatever is the current selected menu item, its state value will be assigned to the current game state. And we make a couple checks to support the up and down buttons. If we press the up button and we're going up on the screen, which will be going down on the menu row index. So long as we're higher than 0, we can go up, like visibly up the menu and down on the index. And same thing in reverse for the down button. I have not tested this yet, so let's quickly compile and test. Okay. Oh, look at that. Oh, I think we've got a logic bug on our down. The up looks good. I think we need to take one off our sort of down handling code. But while we're here, let's quickly test what happens if we press button B, nothing, C, nothing. So now if we press button A, the game state should switch to the credit screen. Oh, and it does, fantastic. Press start to go back, and now let's press A again, how-to screen. And because nothing has changed the main menu's current selection value, when we go back out to the main menu, our selection has not changed. So we go down to Playground. Fantastic. So what we need to do is just handle our bottom of the code. We could also make that wrap around if we want, but let's close the emulator there, come back over to the code editor, and what we want to do is, I think, stop one earlier than what this computes to be. So we'll wrap that in parentheses just to make sure that is calculated first, make it a bit clearer. Might not be necessary, but I like to do these things sometimes. And is that enough? Okay, so that's fixed our looping, our falling off the end of our menu. Let's quickly demonstrate the automatic calculation of how many entries are actually in the menu. So if I've done this correctly, I should be able to just add a new line here. Let's say broken, because we'll set that to a value that we don't know. And we'll just go 42. So now our menu should have an extra entry. And it does. Now what happens if we select that? Because broken and its value of 42 is not a value that we explicitly handle, I think that error handling code I left in there should actually fire off. Ah, it does. Unknown game state, 42. And that's where it ends. Okay, I'll remove that. Now, if we wanted to, we could add some additional logic in our button handler to sort of, okay, if we're at the top and you press up, we could wrap around to the last one and vice versa. I won't worry about that for now. Also down the line, we'll probably want a prettier looking menu with some graphics, and the advantage of implementing separate game states and the menu code in its own file is our main game start entry point back here in main.c wouldn't need to change. We just make all of our changes in main menu.c. And that keeps it nice and contained and easier to manage. One other thing we might do quickly is, part of me feels like we could maybe have a different color for the arrow. So if we want a different color for text, a couple things that we need to be aware of. VDP set text palette chooses what palette SGDK's text built-in text display routines will use. And I think by default, or possibly not able to change it, but I think it uses the last color of the palette. So if we want to set that, change that color, I think the call is going to be set palette color. Oh, that is deprecated, so what does it say? We want to use pal underscore set color. Okay. Pal underscore set color. Now, I think the index here is the full 64 colors that could be used across the 4 palettes of 16. So we're using palette 0 for text, and we want the last entry in that. So the index will be 15, and the value, there are some helper macros. I think we want RGB 24 to VDP color. So that'll take a 24-bit hexadecimal number, similar to what you may have seen with web stuff, if you're familiar with that at all. Basically, a 6-digit RGB hex code. We want all the red, all the green, and none of the blue to get yellow? Or is it red and blue for yellow? Let's go all red, all yellow, all blue. Ah, okay, that's magenta. Well, what if we wanted to use a different color, wanted to set a different color when we draw the cursor, and then use a different color for all the menu lines? I know I did play around with this and I got it to work. I think we just need to set the color we want for the cursor, draw it, change the color back. Let's try that out quickly. Okay, let's see if this is going to do what I expect. No. Okay. Okay, so let's try using a different palette for drawing the cursor and change its color. So for that, we'll want BDP set text palette like we've got on line 31. We'll go PAL 1. And we will want color 31 to be the last color of PAL 1. Draw the text, and now when we draw the label, we will change the text palette back to 0. Let's see if that behaves. Okay, so if we change palettes when we draw the text, we can manage different colors. Okay. One other little thing that we might do to drive home the benefits of states is within our other states, so credit, how to, and playground screen, we might use the palette trick here to essentially use different text for each of the different screens, just showing how the states can sort of isolate actual game behavior or program behavior. So I think for that we will use palette 0, given that our main menu forcibly sets it before it draws things anyway. So we'll copy this code here, and we might pop that in to the beginning of our credit screen. So we'll make our credit screen red because it's just easy to get the hex code for that. The how-to screen, we will change that to use green. No prizes for guessing that the playground screen's text will be blue. Okay, let's give that a go. So we've got two separate colors because we're using two separate palettes while we're drawing the menu text, and then we should go into the credits screen and have red text, green text on how to, and blue text in the playground. So let's go into credits, red text. Now when we go back out to the main menu, because main menu is sort of setting up the text drawing and colors itself, it should be as we expect. No surprises there. Fantastic. Well, folks, I think that's probably a good place to call this one. I've gotten past a little bit of my analysis paralysis, and we've got a bit of a cleaner setup. So just a quick recap. What we have now is multiple separate screen source files, which are designed to allow us to split up the game functionality into different components based on the current state. So we now have a main menu state or screen with all of its code self-contained and basically its own little game loop that calls the per frame vblank process call that you're probably well used to seeing by now. And our main.c file is actually very trim and neat looking. And to further keep our code well organized, we've got GameState's header file now, which has the current game state variable, so it can be updated from multiple source files. An enum, so we can give more meaningful symbolic names to the different game state values, and function prototypes for the game states that live in their own separate C files. So that's going to be a wrap for this video, I think. I hope you learnt something from that, and I hope you continue to stick around as I try and plod my way through making this Mega Drive game. See ya!